Hello everyone, this is Lexi Kay. I'm the Outreach Coordinator at the Environmental Finance Center at UNC-Chapel Hill. On behalf of the Environmental Finance Center Network, I'd like to welcome you to our webinar, Ask the Expert, a unique opportunity to ask your asset management questions or seek advice on how to begin. I will be providing some technical support for today's session. Please take a moment to observe your GoToWebinar control panel. Most of the functions are self-explanatory, but I'd like to draw your attention to the questions section of your control panel. During today's session, you will all be kept on mute to ensure audio quality and minimize background noise. If you have a question, please type it into the GoToWebinar question dialog box. Today we will be doing an open question and answer forum, and we will be taking questions throughout the webinar. We have over 100 registrants for the webinar today, so we will try to get to as many questions as we can. Today's presenters have agreed to share the presentation slides with you, and we will make the slides available as well as a video recording following the webinar on the EFCN website. That's http://efcnnetwork.org. Please allow 1 week for the processing and posting of these materials. Today we are joined by our asset management guru, Ms. Heather Himmelberger, Director at the Southwest Environmental Finance Center at the University of New Mexico. Are you there, Heather?
Yes, I am. Hello, Lexi.
Hi, Heather. We're also joined by Ross War. He's an asset management consultant with over 17 years of experience. Before that, he worked for a municipality. He's visiting us from New Zealand. He has experience working all throughout Australia and New Zealand, and he has expertise in all areas of asset management. He's also the section author of the International Infrastructure Management Manual, and he collaborates on a blog with Heather. Hi, Ross, are you there?
Yes, I am. Thanks, Lexi.
Great. Well, I think we are ready to start, so I will turn it over to you, Heather.
All right. Well, good afternoon or good morning, depending on where you are, and thank you for joining us today. We're glad to have you. Just a couple little things before we start. I just wanted to make mention that this webinar is being funded by the Environmental Protection Agency as part of our Smart Management for Small Water Systems project that is being completed by the Environmental Finance Center Network. And on the screen, you'll see our webpage, efcnetwork.org, and there's a wealth of information there about this project. You can also find past webinars, recordings of those. You can find blog entries, resources, upcoming trainings, etc. So if you want to know anything about the project, please visit the EFC Network website. I also wanted to make mention of an asset management survey that is going on right now by the American Water Works Association. You should have received an email blast from us about a week ago regarding this survey, but in case you missed it, I just wanted to make mention that there is a survey being done. 3 lucky survey participants will receive a $100 gift card that you can use at the AWWA store to buy a book or a DVD or whatever you want. But we're really encouraging folks to take the survey. It will help us determine the state of asset management practice in the country so that we can develop additional resources and trainings and things to help people with their asset management journey. And whether or not you have what you would consider a specific asset management program or not, it doesn't matter. The survey will apply to any system, any size, in any state of asset management practice. So please, if you have a few moments, consider taking the survey. If you didn't receive our email regarding the survey, please let me know. You can email me at heatherh@unm.edu. You can also contact Jennifer Santini at jsantini@awwa.org. And either one of us can help you get the survey, or if you have any questions about the survey, please let us know. And then the last announcement I wanted to make was that there are some energy management webinars coming up. There's an energy management series that's been conducted, so some of them have already taken place and you can watch the recordings. And then there's an upcoming one on Tuesday, June 9th, regarding Find Money and the Water System Budget, Energy Management Project Ideas, Prioritization Methods, and Implementation Planning. So I just wanted to let everybody know that that's coming up on Tuesday, June 9th, and that'll be presented by our sister center at the University of North Carolina, Chapel Hill, David Tucker, and then Steve Kubler will be also assisting on that webinar from Kansas. And then lastly, there are some resources available to you to help you with your asset management journey, and I just wanted to put those up. We can come back to these later, but the infomanage.com website that Ross mentioned, he and I collaborate on some blog posts and various things, and Ross has put a wealth of resources on that website that are available to communities, so please take a look at that and you'll find all kinds of resources there. There are resources on the efcnetwork.org website, and there are also resources on the Southwest EFC .unm.edu website about asset management. So there's a lot of places you can go to get information as we move along. So Lexi, I'll ask if any questions haven't come in yet regarding asset management.
Yeah, we have one question so far, so if others have questions, please go ahead and send them in, but I'll get us started with this first one. We are considering a system betterment program for about 500 miles of water pipe and associated fittings, valves, hydrants, etc. What are the most critical issues we should consider before going forward? Our system is 30 years old and we experience numerous year-round leaks system-wide.
Oh, okay. Well, the first thing that you want to think about is kind of getting a handle on exactly what's happening. So hopefully what you're doing already is mapping where those breaks are actually occurring and really looking hard at what particular pipe type the breaks are occurring in, whether there are any trends regarding the size of the pipe, the type of the pipe, the location of the breaks, and then also the type of breaks, what's causing the breaks. So is it being caused by construction accident, for example, which is very different than degradation of the pipe? Is it being caused by poor bedding materials or poor installation? Is it caused by poor materials? So, you know, what do those breaks actually look like? Because you really want to zero in and make sure that you have a thorough understanding of exactly what's causing the breaks and what pipe type and location they're in, because that can change very significantly what you're going to do about it. So many times if you have a variety of pipe types, the breaks are occurring more predominantly in one pipe type than another. So you want to focus in on, you know, the specific actions that are causing the break, the specific type of pipe, so that you focus your corrective actions. You know, if you're doing leak detection or pipe repair, pipe replacement, that you really focus those on the type of pipe that is having the problem. We often look at a community and they'll say we're having breaks throughout the whole system, but you find out that's not really true. Maybe it's the steel pipe they put in 1970 that's causing all the problems, or there's a particular location where soils are really bad and that's where the problems are. So the more you can focus your efforts on your problem pipe, the better you can expend the money that you're putting forward in that effort.
I think one of the other things to look out for is making sure that you're getting reasonably accurate data coming back from your crews about what is happening. I remember a client with a very similar question, and they were convinced that they had quite a long length of the main line that was in pretty poor condition because they were getting a lot of breaks, and they were recorded as mainline breaks. And when they dug into it, they found out it was service line breaks coming off the main, and they had just been recorded the wrong way in the maintenance management or the asset management system. And they were making a whole set of very expensive decisions around what was inaccurate data. So I guess my suggestion would be validate the information that you're getting, go and talk to the crews that did the work when you're making those decisions, and make sure that they were coding it correctly, and that you're not dealing with the wrong problem through just poor data recording or just confusion around data recording.
Yeah, the more you can zero in on your actual problem pipe, the less money you have to expend to solve the situation. So, for example, if it's 6-inch cast iron pipe that's your big problem, you can zero in on that pipe type and then pick what are the worst areas of that pipe. So you don't have to expend money replacing the entire system. You only expend money replacing the pipe that actually needs it. So really just going back to your data and making sure you have very good data about exactly what's happening, where it's happening, what are the trends, have you seen more breaks over the last several years or fewer breaks, which direction is it going, and then, as Ross said, is it actually the main line or is it something else? Is it the corp stop or a fitting or service lines, to really make sure that it's the pipe itself that's the problem before you go forward and replace the pipe. You want to be very, very sure that that's the problem, because of course that's the most expensive thing you can do is replace your pipe. Generally speaking, that's, by and large, the largest cost you're going to have is to replace mainline pipe. So the more you can reduce that to a smaller segment, the better off you are and the more money you'll save.
And just the final thing there is, I know there's some really good guidance around now about treating different types of pipe and what might be the optimal treatment process. There's AWA have got a manual on that, and there might be some other EPA one as well I've seen, and water research as well, I think, have got some about that. So depending on the type of physical material you're dealing with, just make sure you grab that guidance and read it, and get your thinking around what is the optimal treatment process. It may be, if you've got old cast iron pipe with lead joints, your leaks are just going to be at the joints. You might decide, hey, we're just going to do some joint repacking as opposed to pulling out perfectly good pipe. Other material types, it might be a completely different treatment selection, and that sort of just getting right up to speed with the latest thinking on material types and how to manage them could also guide your program and save you a lot of money, because there's been a lot of research in the last couple of decades, and a lot of that's is in manuals now, and certainly worth reading and just refreshing yourself on that.
Okay, do you have another question for us, Lexi?
Yeah, just a little bit of a follow-up on that. Are there any GIS or remote sensing tools for homing in on water system problems and identifying the areas where you need to do the work?
There's certainly GIS tools that can be used. If you have already, say, a GIS map of your system, one thing you can use is GPS, and take a GPS reading of each location of your breaks. Or if you don't have a GPS very specific location, you can work with the GIS team and say, well, it was at 351 North Elm Street, and they can make a pretty good estimate of where that break occurred and put the break on the main at that location. So you can certainly use GIS tools, and we've done quite a bit of work in that area with some of our utilities, the bigger utilities that have a GIS mapping system. We're getting them to start plotting the break locations so that when you pull the map up, you can see, points on the map, dots or cross X's or whatever you want to put on the map that show the leak locations. So that technology works very well to give you the visual, and you can even have a database behind it where if you clicked on that particular break, it brings up what size pipe, what was the condition of the pipe, what was the thought to be the nature of the break or the cause of the break, so that you could get that information even behind the GIS system. As far as remote sensing, I'm not sure. Have you seen anything with that? I mean, I've seen people use that to locate pipe more so than, leak locations.
Yeah, and you've got your systematic or area-wide leak detection programs that you can have underway. The thing to watch out for with them is, again, depending on the pipe material type, they can be very accurate for locating the leak position. Some of the plastics, I think, is more problematic because you don't get as clean a sound as you do at a metal pipe. So it's just, again, being aware of the limitations of the current technology and narrowing things down as much as you can with the materials you're working with.
Yeah, there's quite a few different kinds of leak locating technologies, and some of them work better in some situations than others. So it is really important, since almost all of them will cost you a fair amount of money to use, to make sure that they're applicable to your system before you invest a lot of money in leak location. You know, make sure you have contact points, which are hydrants, valves, meters, that allow you to listen to the pipe. Make sure it's the pipe type that will carry sound. Make sure that it's technology that works on, you know, whatever you have, and that your crews are familiar with it before they try to use it. So you just have to be a little careful, but there's a lot of different technologies that can be used to help you find leaks. But always remember that no matter what technologies you use, they'll only find so many of your leaks. There's always going to be a few that you won't find, and that's just kind of the way it is. So if there's a real reason to go looking for leaks, you know, just choose a technology that works well with your particular system.
I think there's a rule with this, and it applies to a lot of engineering, but certainly a lot of asset management, and that's that 80-20 rule, which is you're going to spend 20% of your effort, and you'll capture 80% of your problems. And you've got to try and judge where that is, because you can spend a huge amount of time, effort, and money trying to run down that last 5 or 10%. And you just really got to look at the economics of that and say, is that going to be worth it? Because you can get a lot of your gains very quickly and very easily, and then spend an awful lot of resource trying to get the last little bit of it.
Okay, Lexi, do you have another question?
Sure. Can you please describe your approach for setting up an asset or equipment numbering system for a computerized maintenance management system?
Yeah. Okay, so it's Ross here. I'll take this one. I have, for the work I've done in Australasia, that's the section of the International Infrastructure Management Manual that I updated in 2011 around asset information systems and data management. And right now it's getting updated for a 2015 edition, and I've just in the last month had to update that section again. So the thing is that the numbering depends on the type of system you're using. So if you're using a spatially orientated system such as a GIS, you might just want to have a sequential number, because as long as you've got the linkage, and it's say to your pipe reticulation, then that's all you need is that number. When you get into point assets, say your treatment plants and your pump stations and tanks and things like that, sometimes you're going to have a whole lot of assets in that one location, and so then you start thinking, well, I want a schematic breakdown of the assets and I want to number them. And I think the best advice there is that you keep a reasonably simple hierarchy, that you break that hierarchy up into the areas that are logical to the people that are working on it. So for argument's sake, for a pump station, you'd say, right, we've got a well or some description or a chamber, some concrete civil works, so we'll give them all one set of numbers. It might be C for concrete or C for civil. We've got some pumps, so you might start them with a P, so you might have P1 or P2 or something like that. You might have some electrics and control gear, so you might say electrical gear E and start like that. And just start with a simple hierarchy, break it down under that. If you need to be tracking information on your impellers, you might split them out, or your motors, depending on the size of the pumps. But really what you're trying to do is number things relatively simply and in a way that works logically for the maintenance crews, because they'll be the ones that are having to go and attend to those assets and code any work against the numbers. So that's the thing for there. If you're wanting to do numbering against reticulation assets, it can be against street names or as the code or the material. Yeah, more usually the street name location. Those sort of numbering systems, though, I think have fallen out of favour. They were back in the day when we didn't have the spatial linkages, so you had to have a textual hierarchy for reticulation assets. And nowadays, I think everybody starts with a spatial system when they're building inventory, and so you don't need to be so concerned about a hierarchical numbering system for reticulation. But if you do, you just choose street numbers or street names, or if you've got some councils or some authorities might have block sheets, so they've actually got already had a numbering system based on old block sheets. If that's what you're used to, nothing wrong with continuing with that system, assigning it to the asset in the database or asset register. If you end up with a number sequence that's 30 numbers long, then somebody is going, somebody has to put that into a system every time they do it. So I always sort of think keep it as simple as possible and keep it as short as possible. Less room for confusion if you do that.
And one thing to think about is we often hear stories of utilities when they start their numbering system, and they have some pretty good fights over what people want things numbered, or they start down a path and they've decided didn't quite work. So keep in mind when you're first starting, try it out on some assets first. Pick a little section of your utility, try out the numbering system, make sure you're happy with it, it works, people understand it, it does what you want it to do, and then go about numbering everything else. So before you sink a ton of time and effort into it, pick a subset after you've kind of decided on the numbering system you want, try to number all those assets, see how it goes, and if you've had some difficulties with something, adjust your numbering sequence accordingly, and then go forward and number the rest of your assets so that you can just make sure it's working and it's doing what it is you want it to do before you expend all kinds of effort on it.
I'm just going to skip through those slides here. We had a couple of slides on keeping things simple here. So Albert Einstein many years ago made a statement that said, make everything as simple as possible, but not simpler. And I think that applies to a lot of asset management, but certainly to numbering systems as well. And there was another one there from Steve Jobs, which is simple can be harder than complex. You have to work hard to get your thinking clean to make it simple, but it's worth it in the end because once you get there, you can move mountains. And I think, again, right across asset management, but also how you do your numbering, it's keep it simple. I don't know if there's a tendency to do this in America, but when we first started numbering treatment plants or treatment facilities and pump stations in New Zealand, we had people that wanted to go right down to the bolts on the Gibolt joint or on the cast iron pipe coming out of the pump and say, if you go into one level too much detail, you die because you can never maintain it and you spend too much effort trying to get to that level of detail. So one of the things with numbering systems is to have that really robust discussion at the start of the process. Why do we need this information and what are we going to do with it? If nobody can answer that question well, don't collect that information. Come up a level. And a real good guide is at what point do you replace stuff? So for coming back to the bolt on the Gibolt type argument, you should not be tracking bolts through your system. If you're doing that, you don't need to be doing asset management because you've got too much money, basically. But you might want to be tracking at a whole of Gibolt, including bolts level if they're a stock item. So it's just the level you manage information at. And if you go down a level too much, you just bury yourself in too much information. The guys are just spending all day filling out forms or databases, and you'll just end up churning information as opposed to doing work, which is actually what you're supposed to be doing at the end of the day is delivering the service, doing the work, keeping stuff working. So.
Okay, Lexi, do you have another question?
Yes. How would you suggest asset management be initiated in a situation where there is a basic lack of financial resources or skilled people?
Well, that's a very good question. It's kind of the question of where do you start when you kind of feel a little overwhelmed, is what it sounds like, feeling like there's not really the right folks, or you feel a little overwhelmed that you don't have the right information. And the first thing is, I would say you probably know a lot more about your system than you realize, and you probably have a lot more expertise than you realize, and you can start very simply. And you might want to start just simply at a very high level, thinking about what you own. Can I just list out what are the things in my system that I have and where are they located in a very simple map? You can start really, really simply with, just at a pretty high level, instead of breaking a pump into all of its components, just, I have 5 pumps and they're on Main Street, Elm Street, and, East Side Street or something. And I have 3 tanks and I have 2 wells, and, keeping it at a very basic level, and then get a very simple map of where your pipes are as best your operators know, because usually if you have anybody operating your system, they do have a pretty good idea of where the pipes are. And you can develop a map out of something as simple as, going online and spitting out a MapQuest map of your area and drawing on it. You can print out Google Earth. You could even have them just draw the whole thing by hand if they wanted to, as kind of just getting you started. And so as a very, very rudimentary starting point, just getting that list of what you have and where it's at, and starting to think about, what's the collection of stuff that you have, and then you kind of move into what is it I wanted to do. What are the things I'm trying to provide my customers? So a couple of simple level of service goals, like, trying to meet all the regulations, and what customer service you want to provide, what pressure you're trying to operate, thinking about what it is you want your utility to do, is kind of a good way to get started on all of this.
I think I agree with Heather there. That building a very basic inventory to start with is a really great place to start. Simply, even if it's, I've got 100 miles of cast iron pipe that's 6-inch, and it's as simple as that. You really, and it was put in around 1900 or something like that, if it's an older town. Or maybe it's 1950 or whenever the date was. It doesn't need to be any more technical to that, because once you've got that really basic inventory, you can then, in less than a day, you can go and say, well, what if I had to replace that inventory? What am I paying at the moment to do a bit of replacement? And so you can get some rates there at so many dollars per mile, yeah, and then that tells you pretty much what your system is worth. The next step you can look at from there is say, well, how much are we spending maintaining this system? We know it's worth, let's say we know it's worth $10 million. Now, if you're spending $5 million a year, as a ridiculous example, maintaining a $10 million system, something's not right, because your maintenance should be a 1 or 2%, depending on the age of your system, per annum. It might even only be 0.5% of your value. So you can start doing some very simple math that allows you to then start pinpointing where your problem areas are likely to be, and just being able to look at that inventory and say, oh, we've got some very old pumps here that are quite near the end of their life. We should be starting to think about what we're going to have to do with them when they end their life. Or we've got an area of the reticulation that we're getting a lot of breaks in, and it's costing us far too much. And that starts the conversation internally about where you have to, what the next steps are. But it doesn't have to be based on a huge amount of sophisticated analysis. It's really quite a simple spreadsheet or an inventory will get you over the line with that.
And just on the financial side, I know there was also a part of that question related to the financial end of things. There is a very simple tool that the University of North Carolina Environmental Finance Center set up that's a nice rate setting tool. And you can go online to the efcnetwork.org website under resources and tools, and you can download that for free. and that's a tool that you can use as a simple way to get some rate setting started. So that's something else to think about if you want to get more into the financial side and looking at what your rate should be. That's a nice simple tool that you can use to kind of get you started looking at what should be in your rate and what your rate should be, because certainly you're not going to have the finances if you don't have any idea of what rate to charge and you haven't been able to get the money you need through rates. So keep that in mind as well, that there is that free tool available to you that can help you get started on that end. Okay, Lexi, do you have another question?
Yes. So this is coming from one of our participants. We have an elevated water tank, it's 21,000 gallons, with possible holes in the roof and perhaps birds resting on the tank. It all must be replaced. What is a good short-term, cheap solution?
Well, that's a very good question. If there is a hole in the tank and there are birds at the top, that's certainly a huge public health concern. We had some data, unfortunately I don't have it at my fingertips at the moment, but we had some data that was taken a while ago when there used to be a lot of tanks with floating roofs that bird droppings would get in, that many of the water disease outbreaks were caused by holes in water tanks, particularly by bird droppings. So it is a very serious concern in terms of public health, and it is something that needs to be addressed in a very, very quick fashion, unfortunately, because you do have quite a potential, and again, if that's true that there are holes in the roof and there are birds up there, there is a big potential for contamination to get in the system, and you don't want anything to happen with disease outbreaks or anything like that. So it is something that is a very serious concern that should be addressed very quickly. That being said, in terms of what approach is the best to repair a tank, I have to confess I don't know repair techniques for tanks. Maybe Ross does, in terms of what specific techniques can be used.
Well, I'm thinking, and I've had situations like this back in the days when I worked for a municipality that ran a water utility. But I'd like to talk to the question perhaps a little bit more in terms of asset management principles. So what we've got the description of is an asset, and it's going to be a reasonably expensive asset to replace, that has either got some major maintenance problems, or in fact that might be just the indicator that there's other problems up there as well, and you might need to replace the whole asset. So from an asset management planning point of view, the first thing you want to do is get a better idea of the condition of the asset. Is it something we can just repair by resealing the roof or sealing that particular hole? It's just an isolated problem, in other words, and you could run the same analysis on a pipe main or any other type of asset. Or is it a wider spread thing? Is the whole tank is actually getting quite near the end of its life? We're going to get more holes, more problems, because you're trying to make a decision there. Is spending money on this tank in its current condition just a waste of money? It's only going to hold us for a year. Or is it just one isolated little problem, and so if we spend a few $1,000s fixing that hole, then we're going to get another 20 or 30 years out of the tank. So once you know that, if it's a simple repair, then you're going to put the work package out or give it to your crews, and the biggest thing with elevated tanks, of course, is just the whole safety aspect of making sure that whoever's working on it isn't going to fall and those sorts of things, and maintaining the hygiene and everything up there. Sometimes you can take the opportunity to clean and repaint the tank while you're doing that sort of work as well. So take it offline and actually do the whole job, get some more life out of it, if that's your approach. If it's going to be like this tank is really right at the end of its life, and we've looked at the pedestal and it's got problems as well, and it needs structural work, and the list goes on, and it's just getting too expensive to repair, then you're into replacement. And then the question is, do you go for another elevated tank, or do you put some ground tanks in with some pumps? And really that's just a straight engineering analysis on cost benefits. Obviously elevated tank, you may or may not have additional pumping. Certainly if you're going to put ground tanks in, you're going to have some sort of booster pumping or something like that. And so you've got wear and tear on the pumps through the life of the asset, and also the energy costs and the maintenance costs of the pump. So you can run those numbers out. And the thing is, she's saying, well, what's the life of the tank? If it's 30 to 50 years, what over the same period of time is going to be the most cost-effective solution that there is? And so you could just do a quick analysis, trade those things off against each other. The answer will drop out, and then you'll have a way forward. The only complicating matter is if you've got your authority has policies about how they're handling elevated tanks, or there's a state or a city policy they're trying to get rid of elevated tanks for some reason, and that might change the dynamic of your analysis.
Okay, Lexi, do you have another question?
Sure. If a utility wants to start tracking the minimum life cycle costs for their assets, what are the most important actions they should be taking to do so?
Well, I would say one of the most important, and it's something we see over and over and over and over again, is that people are not tracking costs on a per asset basis, or even in a per component basis. Like if you wanted to break your system up into, say you have 2 pump stations, 3 wells, some pipe, something like that. The costs, a couple of tanks, the costs aren't even broken down by tanks, by wells, by pumps. Generally speaking, you'll see your operation and maintenance costs just in a big lump. And people might know I've spent $20,000 last year, but they have no idea if that $20,000 was spent on pipes or pumps or wells or whatever.
All above ground stuff.
Right. So a lot of times we don't have costs that are broken down so we can see what people have actually done. Without that kind of detail, it's really hard to make decisions about how much have I spent on a pump over time, how much have I spent on a well. Is there one pump that's causing most of the maintenance, meaning that one might need some, maybe that leans towards a replacement, whereas my other pumps are doing just fine, and that if I continue to repair those as they break, I'll be doing well. So I would say the most important thing you can do is start tracking costs at a minimum on, a component basis, saying at least I'm tracking them by a pump station or a wells or tanks. So starting there maybe as the very beginning, but then digging deeper and saying each pump, each well, each tank, how much am I spending on pipes, to the extent you can, tracking it to the piece of pipe, because the more you can break it down to those individual components, the easier it starts to be to make decisions about what to do with repairs and replacements. When you don't have that data, you're kind of flying blind because you really don't know what's happening. You don't know how you're spending your time and effort. And as one example, we were looking at some data for a utility that did finally start tracking very specific work activities that their crews were doing. So everybody had to use a code so we could know, what kind of activity they were doing. Were they doing a pump lubrication? Were they doing a pump repair? Were they doing outside yard work? And there was a way to then track how many hours were spent on each type of thing. And it turns out that they weren't spending their time the way they thought they were. The bulk of the time was not being spent on pump maintenance. It was being spent on outside yard work to keep the pump station sites looking good. And you don't know that until you start to track the data and look at it. So the more you can break those individual activities down so you know what you're doing, you know what money you're spending on it, you know what spare parts are being put in it, that really detailed level data on a per asset or per component basis really helps you start to make those decisions.
And of course, what Heather's been describing presupposes that you've got an asset inventory of some description that allows you to hold that data as you're collecting it against that level of component. Just as Heather was describing that, remembering a client of mine, and they had a lot of old cast iron pipe, and for some bizarre reason best known to themselves as a municipality, they had galvanised iron service feeds into the houses. And they started splitting it up so they could track the cost just as he was described, and found out that these galvanized pipes were just costing them a fortune. They were corroding, they were blocking up, they were splitting, they were pinholing. Any possible problem you could have with a metal pipe again with those. And so for a couple of years they tracked those numbers, and just the maintenance costs were out of all proportion to the lengths of pipe. So they went back to their in their case they had a council, not a commission, but they went back to their council and they said, look, we're just spending far too much money on these galvanized pipes, and we've done the math on a big replacement program, and we, over 5 years we're just going to get that money straight back again. And they'd had a lot of trouble getting the extra money for replacement, but when you get really good math like that, everybody just looks and says, well, hey, do it. And so they raised a loan, I think, and in their case, and got on, and over about the next 5 years replaced or swapped all those pipes out with new pipes, and their maintenance costs after that were really quite low, and everyone was pretty happy, because when your service line's blocking or breaking all the time, people are out of water, they get grumpy, and when you've got pipes that are effectively rusting from the inside, you're getting a lot of staining with the washing and things like that. So the householders were really happy when that was all fixed up. The main lines were fine, the cast iron. It was just the service line. Until they'd collected that information, they just didn't know what they were dealing with. And once they had it, it was really, the path forward was very, very clear, and particularly in terms of getting a lower total cost over perhaps a decade.
And I would say, too, that some of the systems that hadn't previously collected that kind of data, but then started to collect that data, start to see that they're spending their time, as kind of a human nature sort of thing. We spend a lot more time with assets we can see, touch, visualize. So a lot more time gets spent on things like pump stations, the outsides of tanks where you can inspect the outside, and a lot less time gets spent on pipe and wells where it's a lot harder to see them. So until you start tracking kind of where you're spending your time and your money, you may not be aware or as conscious of the fact that you're not universally, giving equal routine maintenance around the system. You're kind of giving more maintenance to certain assets and less to others, because it's easier to do some of the maintenance than it is to do others. But if you start tracking that, that gives you the chance to say, you know what, we're really ignoring our wells, or we haven't looked inside a tank. I actually talked to somebody who hadn't looked inside their tank for about 30 years. And that's kind of not really where you want to be. You want to actually know what's happening inside your tank. So once you track again, you start tracking things on an asset basis or an asset class basis, you start to see where you're spending your time and your money. And you can shift that if it seems like you're spending it in the wrong places or you're ignoring some assets. So, in the one case, if you see multiple pumps and you can see one that you're spending way more money, that tells you about that pump versus the others. But it can also tell you assets that you're completely ignoring and saying, we haven't looked at our wells for, 10 years. We've basically done no maintenance. So we really ought to get on that, because we haven't been pulling pumps, or we haven't been checking drawdowns, or we haven't been cleaning out our screens or anything like that. And that could cause a problem later. So again, it will help you really understand what you're doing within your system.
You had a good example recently around air valves, didn't you, that you'd help somebody?
Yeah, we had a utility that talked about some air release valves, and that was their biggest problem within their whole system, was they were spending a lot of time with leaks in the wintertime. And it turns out they just didn't really have a good handle on the type of maintenance that needed to be done on those valves, or how it should be done. And as they developed a program to say, well, we need to spend some time there because that's our #1 problem, they could develop a whole maintenance program that said, okay, we need to do this in the fall and this other maintenance in the spring to make sure that we're ready in the winter to try to prevent these breakages of the air relief valve. So they were able to design a whole program around what to do with an air relief valve. And because that was their #1 expenditure, as these things were breaking, they were spending a lot of time and effort. It was probably their #1 thing, and they could design a program that would try to prevent that expenditure.
And coming back to the original question, when you get ahead of the curve and you get on top of that preventative maintenance, so you're not getting all the call-outs in the middle of winter and all the problems associated with that, that really starts lowering your annual cost and your long-term life cycle cost of delivering your service.
Okay, Lexi, do you have another question?
We sure do. We've talked a lot about numbering assets, but what about water distribution pipes? Is there a recommended numbering system that will uniquely identify each particular distribution pipe after it has been installed?
They're talking about the pipe network, so how to identify individual pieces of pipe within a network. So if you have, mains and laterals, how to identify the pipe number.
Well, therein lies an argument in our industry, because some authorities will want each individual piece of pipe to have a unique number. So you start at a T at an intersection, you come out to the valve, and there's a piece of pipe between the T and the valve, so we want to have a number on that. Then we've got the valve, then we go from the valve down to a junction, and we want that one numbered, and then we go down to the next piece, the next change. So that's one way of doing it. The other way of doing it is to take a piece of pipe and say, block to block, we will number that piece of pipe from one block to the next block. And we've had this, out in our part of the world, we've had this argument go backwards and forwards. The people on both sides of the argument are convinced that they're completely correct. So, and there's no agreed position. I tend to, where I start with the thing is saying, what do you replace? And it's a really interesting question. There's a subsidiary one to that, particularly with hydrants. If you've got hydrants sitting on top of a pipe and/or valves, I don't know what the practice is here in America, but when we're replacing a block to block of a pipe, we'll fit up new hydrants and valves. We don't use the old ones. We might recover the old ones, but we're not going to. Whilst what you do is you leave the old pipe in service while you fit up the new one and get it all in, and then you swap it over at the last minute. That's the practice in our part. It was the same here, I assume.
Yeah, there's very likely, if you're replacing pipe, typically replace all the fittings.
Yeah, at the same time. Yes. Yeah, you're not going to try and recover old fittings, because that's just, you might like to think you're going to do that as the engineering manager, but I tell you for sure the guys who are doing the work won't, because that's just too much like hard work. So the thing is, what I say to people is, if that is your practice, you're fitting up new when you replace, and that's new hydrants, new valves, all new cast iron fittings, then the life of all of those is effectively the life of the pipe, because you're going to replace them, effectively either pull them out or leave them in the ground when you do the replacement, put the new piece of pipe main in. So that changes your life, because people have had very learned arguments that a valve's got a 100-year life and this pipe might only have 50 or 70, or it might be 200 or whatever. So it's getting your asset lives sorted. Then how big of blocks of pipe do you replace? And that comes down to the practices at your own utility. Some people will replace very short lengths of pipe, in which case you might want to track that change. Other authorities say, look, if we're going to replace, we actually do the whole street. We don't come in with a big crew and only do 10 feet or 20 feet of pipe. It's just once we've mobilised and got on site and we've got really old pipe there, we do 100 feet or 300 feet or whatever the figure is. So so it's really how you number your pipe sits around how your maintenance and replacement practices work. Coming back to that idea of keeping it simple, the more elements that you introduce into your inventory of small pieces of pipe. So if you've got little 3 feet pieces of pipe in your inventory that you're tracking, how is the person on the field going to assign the work to the right asset at that short length? So you just got to think your way through those. The risk you run if you have lots and lots of small pieces of pipe is you're introducing complexity that you can't manage in terms of your inventory and also your field recording. If you are going to do that, then it comes back to that same question. If you're using a spatial system, you would break those up in your GIS, and then you would the GIS assigns a number to each individual element of GIS, each pipe element or line or point element that it has. So you can just grab that number and assign that. If you want an alphanumeric or an intelligent numbering system, then you've got choices around effectively the road, the name of the road, and all the chainage, all the mileage along the road is often a way that you'll do that. But it's just, again, comes back to how your practices are, and maybe you might have a different a V for a valve and a H for a hydrant or something like that as a N descriptor, or P for pipe. So those are sort of the two ways that you can do that.
Okay, Lexi, do you have another question?
Sure. EPA has a publication, Getting Started with EPA's Asset Management and Debt Capacity Tool, but I can't find a download for the tool. Do you know where I can find a download for this free tool?
I don't know right off the top of my head, but what we will do is find out where we can get that download, and we will send it out to the attendees of the webinar, because I'm not 100% sure where that's located, but we will find that, and we will make that link available to those attendees on the website, on the webinar.
Great. Well, that was our last question for now. So if you all have more material you'd like to cover, we can give folks a few minutes to send in their next round of questions.
Sure. What we wanted to talk about, Ross and I were discussing what are some of the big issues that are happening in asset management? What are some of the big things that we've seen around the country as I've done training pretty much from one end of the country to the other? And one topic that I wanted to bring up with Ross was the issue that keeps coming up over and over and over again, which is, how do we talk to our governing bodies? How do we get our governing bodies? It might be a board, it might be a city council, it might be a county commission, whatever it is that's, whoever it is that's governing your water utility. How do we get them engaged in the asset management program? How do we get them to understand what we're doing? How can we get them to support the program? And that seems to be a very, very common question that we get is, how to engage them. So I thought, since we have Ross here, and many of the communities in New Zealand have had pretty good luck getting their governing bodies engaged, so I thought we might ask him about that issue and any suggestions he has for us. So go ahead, Ross.
Okay, so I thought I'd answer this in three answers initially. The first one is, when you're dealing with your governing bodies, and we have exactly the same issue in New Zealand, and I know in Australia they have the same issue as well, I think you've got to remember that you're an industry professional. This is your job. You do this day in, day out. You think about it every day for 7 or 8 or 9, or if you're mad, 10 or 11 hours a day. That's me. I'm talking about being mad. I live and breathe this stuff. But the elected rep is not a professional in your industry normally. So they might be from a completely different professional background, and so they don't know is the first thing. They're on this board or this commission or whatever, but they don't know the level of detail or have the professional training that you do. So the first thing that comes out of that is that you have to communicate with them, and you have to keep communicating. And when you think you've communicated enough, that's normally only about 10% of what you need. And it's a communication and an education. And it's not treating them like dummies or anything like that, but it's just realizing that they don't have the background that you have of knowledge, and that you have to bring up that knowledge background as you work with them, and have to keep communicating the ideas and concepts to them. And at that level, making sure that you repeat that. And remembering too that with your election cycle, if it's full in New Zealand, it's only 3 years, so we can have almost a complete swap over in 3 years. Often it's not, there'll only be a few people, but you have a 4-year cycle here, so you're going to get new people. So this is a cycle you have to get into, because these are the managing utilities is a long-term job, and so you have to keep educating and keep communicating with the governance layer, or the governance boards. And that's just something you need to build into what you're doing, because it never goes away. So that's number one. Now, the second thing is that as industry professionals, we love to get into detail because we know what we're about. We have all these acronyms and we have all these codes we talk in, and we sometimes talk in really quite detailed technical stuff because we understand it. Now, the governance people will not understand that level of technical detail. And some years ago, we have our regulator for our water utilities in New Zealand is the government-appointed Auditor General. They audit all the public federal government books as well as all of the utilities. And the guy who was the Auditor General he'd been around for a long time, and he was a pretty wise guy. And we had this mandated production of asset plans and long-term financial plans associated and expenditure. And he read all these, or his staff read all these, and he came back after it with a really insightful statement. He said, you know, you guys have done really, really, really great technical detail, but it's too technical. He said, you've lost sight of the big picture debate in the technical detail. And so he challenged our industry, the utilities industry and the municipal government industry, to have the right debate. So what he was really saying was, once you've gone through all the technical detail, what is if you had to pick 1, 2, 3 big picture, 1 or 2 sentence items that said this is what our problem is, or this is what we need to fix, what is it? And you think, oh yeah, that'd be easy. It's a lot harder than you think, because a lot of these issues are multi-layered and quite complex. But if you can come up to the level of your governance and have a very, this is what we've got, this problem, all our tanks are falling to bits in the next 5 years is our problem, and we need $50 million to fix it, or whatever the figure is. And it's as simple as that. Then the governments are going to ask you, are you sure? And you're then going to talk about risks and condition and that assessment and your legal requirements and things like that. But once you've had that sort of discussion, they've got a very clear idea about what they're talking about. And I think it's very easy as technical professionals to bog down in detail, because that's what we deal in every single day. Now, the third thing I want to talk to you about is the town I actually live in. And some years ago, back in the late 1990s, it became apparent that our main wastewater system needed to be replaced at the same time as there was some, in your terms, EPA regulations that were changing the whole treatment system. And so for a period of around about 2.5 years, there was a consultation group formed that had the environmental people with environmental concerns, and there was tribal people in our area, and there were the businesses, and there were the big industries, and people from the council, and people from the government, EPA, those sorts of things, all sat around the table for around about 2 years and thrashed out a compromise or consensus over that period of what the go-forward should be. And what it turned out to be was, for a town of 27,000 people, it turned out to be a $65 million program that was executed over 15 years. It required the charge for wastewater to double. So prior to the program starting, I think it was about 300 New Zealand dollars a year, and that's very similar to US dollars in terms of income parity. And it doubled to $700 a year, and it stayed at that. It was only just finished the program this last couple of months, and because that consensus had been built, and everybody had gone back to their particular groups, and the paper had been involved, and it stuck. There was not a murmur about the tariff doubling. And then the municipality who looked after the utility just got on and did the work over 15 years, and it just did it well, and the whole thing's just been finished. But the key to that was the time taken to communicate and build that consensus. And I think in anything with governance or politics, when you do manage to be part of forming a long-term consensus in the community about what needs to be done, they stick. Everybody takes the time, they get a broad agreement, and then if there's extra money required, that gets agreed to too, and then that sticks. The community says, yes, we've agreed to this. The governance boards even though they're getting changing people on a 4-yearly cycle, know that the whole community is behind that. So the debate changes from, oh, we don't want to spend any money, to we're making sure that what the community wants happens, and it's quite a different conversation. So I think it's well worthwhile spending the time communicating and building wide consensus in communities about the action that's needed, even though it takes a lot of time and effort.
And just one more thing I want to mention on the governing bodies is one thing that I think is a huge problem right now in the water and wastewater industry is that the governing bodies have the decision about the finance, but the managers and the operators of the water and wastewater utilities have the risk. So the governing bodies make decisions about the finance part, whether I should spend money on a new tank, a new well, a new pump, whether I should have more maintenance people. They're making the decisions about the budget and the rates and all that sort of thing, but they're not really taking on the risk part. So we have our operators and our managers who are kind of trying to keep everything running and keep the risk down, meaning the risk of a pipe break, the risk of a tank failure, the risk of the system running out of water, all of those risks that exist in a water utility, or the risk of a breakage on the wastewater side, or the treatment plant failing on the wastewater side, pump station not pumping, those kinds of risks. And you might know as an operator or a manager that if I don't get money to make some sort of repair or be able to do my maintenance, I am going to have a failure and something bad is going to happen. And that risk doesn't always get transferred up to the governing body who makes the choice of the funding. So unfortunately, we end up in a situation where people are making funding decisions without fully understanding the risk that they're taking on. And then the poor operators and managers feel like even without the money, I have to prevent that situation from happening. So the risk is down with the operators and the managers, and the finance decision is up with the boards. And to get some of this dynamic to change, where the governing bodies accept asset management, support it, support the operators and the managers, we need to start figuring out how to transfer the risk discussion up to the boards as well, so they're fully understanding, like Ross's example, where the community had, the governing body had to understand the risks involved with not raising rates, not providing funding, so that it's not a decision in a vacuum where the only reason I'm keeping rates low is to keep customers happy. They have to understand the flip side. If I keep those rates low, a tank is going to fail, pipes are going to break, and sewage will spill out. They have to know all of the risks that they take on when they choose not to fund a project or raise the rates. Okay, Lexi, have any questions come in?
Yeah, we have a couple. Let's see here. How will the state revolving fund conditions for facility sustainability plans to be developed to receive SRF funding help drive asset management? How can we best integrate Cmom into both asset management and fiscal sustainability plans?
I am certainly an advocate that I hope the the financial sustainability plans are a huge driver for asset management. I personally see them as sort of a subset of an overall asset management program. I think they're an excellent driver that if you're looking for funding, it makes perfect sense to me, and I think Ross would agree, to say that funders want to believe that if they're giving you money to build something or repair something or replace something, that you're going to take good care of their money, that you're going to put in new pipe, new tanks, new wells, whatever it might be, and after that you're going to take very good care of the equipment that you have. So they have a big reason to want you to do an asset management program, because they want to believe that you'll be good stewards of the money that you're receiving. So the financial sustainability planning process that's built into the Clean Water Act State Revolving Fund is really like a few components of an overall asset management program. And one would hope that anybody who goes down that path to do a financial sustainability plan will then choose to go all the way and do a full asset management program, incorporating all the elements of the financial sustainability plan. So the financial sustainability plan talks about things like your critical assets, but you want to go beyond just your critical assets, because what's critical today is not the same as what's critical tomorrow. So if we're not looking out ahead, 10, 20, 30 years, something that isn't critical today very well may be, without our attention being paid to it, a critical asset for us, in 20 years, 30 years. So we want to go with the FSPs, the financial sustainability plans, as a perfect starting point, and then move that into a full-blown asset management program where we're trying to make changes within our wastewater utilities. And then on the water side, there are some SRF programs that are giving incentive points for doing asset management. So you might get more points on your application. For example, Kansas is doing that, where you get more points on the SRF application if you do asset management. And again, I think that's probably going to increase over time. There'll be more state revolving funds that will want to see asset management programs. And I say use any driver you can find. And if the FSP requirement is what is a driver for your community and a way to get your boards or your governing bodies or your managers on board to get you started in that program, use that driver all you can, and use that as a way to get started in a program.
I'm just going to, can we come down this slide?
Yeah, just hit pinch down. Oops.
Just going to pull up a slide here. Oh, the wrong way. That's right. This diagram here, yeah. So okay. This diagram that we're looking at on the PowerPoint at the moment are the key components of infrastructure asset management. And so when you're linking that to going to even a financial sustainability program, for any utility, you need to know what levels of service you're delivering at the moment. You need to know whether you've got what your future demand for your services, whether it's, if you're a shrinking town, it's going to be less. If you're a rapidly growing town or city, you might have more demand and need more sources and more pipework and things like that. And you need to know what risks you've got around that service delivery and that demand and around your existing inventory. That drops into your life cycle management, so that's operational maintenance, renewals, new capital improvement programs, asset disposal. You're going to look at how you optimize that for your minimum life cycle, sustainable life cycle cost. And then that drops ultimately across into your financials, your expenditure, again on operations and maintenance, renewals, capital, maybe some depreciation, and your revenue. Are you going to get your money from fees, charges, tariffs, loans, grants, funding, bonds, anything like that? So there's two sides to the financials, both your expenditure and your revenue. Somewhere along the line, you'd hope they match up. And they often don't when you do the analysis. Now, to be sustainable, you need to know most of that, because otherwise you could write a plan. But if your town is going to be half the size it is now in 20 years' time, that plan is going to be based on a whole lot of wrong assumptions. If your service levels are quite low at the moment and you're below EPA standard, then you're going to, or mandated standard, you're going to have to bring your standards up at some stage to meet those mandated requirements. If you don't do it in good time, then sooner or later somebody's going to make you do that. So and these all have costs associated, and sometimes with your critical assets, that's all part of your risk component. So moving on from that, once you've had a look at that, you've got to look at your gaps as well. And they're not always gaps upwards, sometimes they're going to be gaps downwards. I'm providing a level of service that people don't want to pay for anymore. Maybe we're going to have to drop the level of service. Our town's not growing, it's shrinking. How are we going to manage that in terms of the sustainability of our infrastructure? And sometimes you look at your risks and maybe decide you want another career, or at least you need to talk to your, as Heather was saying, talk to your governance. And then in the terms of the asset management process, you just cycle around that. It's just you work it all out, and then you start resolving assumptions, and you have another go at it, and on it goes. But in terms of producing a financial sustainability plan, a lot of the things that you need to put in there are already in this diagram. And so, as Heather said, it's not that much extra to actually get to doing infrastructure asset management, knowing how sustainable your long-term service delivery is. And if you've got current expenditure at a level, and this analysis shows that it should be twice that level, and your revenue's already struggling to meet existing expenditure, that's a really great starting point for a conversation with your community and with your governance board. Hey, this isn't sustainable. Yes, we can get some loans or some grants or whatever else, but we've got to talk about how we make this work. And then that's a discussion and a communication issue. But they take a while. They can take 5 years, sometimes 10 years to finish having that discussion. But at the end of the day, you'll get some really clear direction from both the regulators, the EPA, and your community and your board or your council or commission that says, this is what we want to do. And this is why we think it's a good idea. And at that point, you execute or you go look for another job, I guess. So.
Okay, Lexi, do you have another question?
Sure. Can you talk about asset management as a part of your operating security system? How much security is enough in today's risk management world?
And I'm assuming that the question, and please type in if this is not the proper way to assume what the question is talking about, but I'm assuming they're talking about security in terms of security of tanks from people breaking into the fence, or, you know, security from that standpoint of people doing bad things to your water utility, you know, maybe wanting to put something in the water that shouldn't be there, or breaking into your pump station or something like that. So I'm going to assume that that's the kind of security they're talking about. And it's a little bit of a difficult question to answer because it makes a big difference where you are in the country as to what your risk is actually going to be. And we have to be a little bit careful that we don't go so far overboard trying to say the risk of somebody doing something bad to our utility is worth tremendous cost when we're ignoring things that might be far more risky to us. So as an example, we worry a lot about somebody breaking into our water utility and adding a chemical that shouldn't be there. So maybe going into your tank and cutting the lock on the hatch and dumping something in a water tank, or hooking into a fire hydrant and overcoming back pressure and putting something in that way, or maybe even through the house, you know, overcoming back pressure and going backwards into the system. But then we have a situation in West Virginia, what was that, about a year or 2 years ago, where there was a spill of a chemical from a storage tank that, you know, overflowed its containment basin, got into the river, and contaminated a water supply. And that was a very real risk that could have been easily identified, and we didn't take proper precautions there to address that kind of risk, whereas many utilities are spending a lot of time figuring out how to get, you know, more fencing, more locks, more TV cameras, security, and that type of thing. So I think sometimes we go a little bit overboard looking at risks that are perceived to maybe happen sometime, and we ignore the risks that are right there in front of us that could be far greater risks, like the individual who wrote in about the tank that has the holes with potential bird droppings. That's a very, very serious risk of public health concern that deserves a lot of attention, and we want to make sure that we're not spending tremendous time, money, and resources on a risk that maybe isn't all that, you know, high of a potential for us, and ignoring a risk like the public health concerns. So we have to balance. I mean, it's not like we don't want to be protective. We want to put our fences up. We want to keep, you know, our facilities as secure as possible, but we don't want to go so far overboard that we spend lots of time and money and effort on some security risks without worrying about the real risks that are right in front of us.
And just picking up on the part of the question about how does that fit into your asset management planning. So clearly what you're talking about there is a part of the risk management section of your asset management plan, that sort of analysis. But also it can fit into your levels of service. So coming back to the, was it West Virginia example, you might have had a look at that risk ahead and said, hey, we've got a contamination barrier risk in our water source if we get that sort of incident. So you may have put some additional filters or some sort of shut-off system or something like that. So that becomes a level of service gap that you would then need some new capital to address and things like that. So again, I'm just going to up a page on this diagram. So when you do that sort of analysis, you spot your gaps between your levels of service or your risks, and then that feeds into your life cycle management, which can include capital to address that. Back in New Zealand, every utility is required to have what's called a water safety plan. It's more around the barriers to contamination than it is around bad people doing bad things. So it's, but you've got to work your way through. How can your supply get contaminated, and do you have sufficient barriers or sufficient systems in place to address that? And so that's a mandated requirement, and government agencies check on that. Everybody has to have them signed off every so often, and so they feed into our levels of service, and then through that into our life cycle management. The only other thing I'd say when you're looking at these sorts of risks is don't forget about cyber risk. It's more and more of your process control instrumentation now is capable of being hooked up to the internet. It's very convenient to do that, to get the signals and stuff back to your office or back to your control center. The thing I always say to my clients is just make sure you've got some gateways or some one-way traffic so that nobody can come in the other way and get into them and start meddling with your control programs, because that would be frustrating in the extreme and also could be potentially quite dangerous. So it's just thinking through your cyber security and stuff that's hooked up to the net that has real-world actions, and particularly control systems. You need to make sure you've got them really locked down so that nobody can get at them through gateways or one-way passage of data, those sorts of things. So, but it just fits into your risk section, and it can fit into your levels of service, and then that feeds into your life cycle management.
Okay, Lexi, do we have any more questions?
Just a follow-up to that, how should redundancy affect risk ratings?
Well, certainly redundancy has a big part of the criticality, and there's a couple different ways you can do it, depending on how complex or how simple you want to be. So in the simpler way, of course, the simplest way would be to have the probability of failure rating times the consequence of failure rating equals your risk, and include redundancy in your consequence of failure rating and reduce that rating if there's redundancy. So if there's 3 pumps and you only need 2, your consequence of failure is a lower number. So that's a simpler way, because you still maintain just 2 numbers, a probability of failure rating, say from a 1 to 5 or 1 to 10 numbering system. You have a consequence of failure, 1 to 5, 1 to 10, and you reduce the number. So instead of being, say, a 4, it's now a 3 or a 2 because you have redundancy. So that's a simple way. A little more sophisticated way is to keep a separate rating for your probability of failure and your consequence, and then add a redundancy factor. The redundancy factor is 1 if there is no redundancy, so the risk stays the same, and it's less than 1 if it's got some redundancy. And you have to decide within your utility, what number do we want to use if it's 50% redundant, or what number do we want to use if we have 75% redundancy, or 30% redundancy, or 100% redundancy, keeping in mind that redundancy does not ever take risk to 0. Very, very important concept, that no matter if you have redundancy or not, the risk is always going to be there that you could lose all of those assets. So say you have a power failure and all your pumps are hooked into the same power source, and the power goes out, even though there's three pumps not working. So you have, you know, some risk that it's that they're all going to fail. So we never want that number to be 0. So it's a number from, you know, say 0.1 or 0.2 up to 1. And within a utility, you kind of decide, you know, what numbers do we want to give different levels of redundancy. So you would take your probability of failure times your consequence and then multiply it by that redundancy factor to come out with the risk score. And the more redundant, the lower the risk will go. And we always say that a lot of times that's really the only way to reduce your criticality, is to have some redundancy. There's certain assets that are just going to be risky. So if you have, you know, say one well supplying your whole town, there's a risk associated with that, a pretty high consequence. So if that well fails, you know, the whole town is without water. So the way to reduce the risk of that asset would be to put in a redundant well, so that if something happens to one well, you have another well that you can use. So many times, you know, we have to have redundant assets, or, you know, in piping networks, we're often very looped, which means that we have very redundant piping networks. So if the water can't be fed one way because of a break or some problem, we can feed it another way. So there's quite a bit of redundancy built into most water networks. Most of the time, there's, you know, other ways to flow the water. And then I think Ross is going to talk a little bit about the resiliency side of redundancy.
I sure am, because being from New Zealand, we had that big earthquake in Christchurch about 4 years ago, and the conversation changed as a result of that from redundancy to resilience, because you can have redundancy and still not be resilient. And because we lost in Christchurch and some of the surrounding areas, you know, lost whole pump stations and treatment plants that got broken up, and lots of pipes that were broken, and guess what? The power network was down as well, so all the electric pumps that didn't have standby generators next to them weren't working, and on it went. And what you start thinking about is, okay, is my network, or is this part of my network, which is really important to me, not only redundant, not redundancy building, but is it resilient? And so you start looking a little bit wider than just your assets and saying, well, if there's some if other things fail, what does it do to me? If I have a big event of some description, and an earthquake's certainly in that category, then how much do I lose? How much of it is going to get damaged? If it's going to shunt the bridge off its pedestals, does it take my pipe with it at the same time? Am I in any position to repair, you know, a 2 or 3 foot pipe? Do I have the components around if I lose some of that? And I know in the US you've had some experience of that with the likes of Katrina when that came in, and other big events like that. So you start looking a bit wider than redundancy and start looking at resilience. We had a case in a different area in New Zealand, a reasonable sized town for us, that had some very big tanks, water tanks up on a hill. They had 3 feed lines, and they were a reasonable distance apart from each other. But what happened was, they didn't have any burst valves on the tank, because there's always a question, you know, if you put burst valves on, they can be a pain in the that will stop working, cause you problems. But one of the pipes let go, and it was a fair way from town, and it was in rugged country, so it took them a while to get out there. And because it was draining these big tanks as fast as it could, there was a big scour zone, and the scour zone from one pipe took out the second one. You know where the story's going, because the scour zone from the second pipe and the first one together took out the third pipe further down the hill, because it's always coming across the hill the way the scour worked. And so they thought they had heaps of redundancy and some very big tanks that were all, not just one tank, but I think they had about 4. And by the end of that afternoon, they had no water. And not only did they have no water, but they had no way of getting that water on, because they had a really big scour hole and no tanks with no water in them. So, well, the tanks were there, but they had no water. And so they had to do all sorts of emergency stuff, and everybody in the country got to hear about it because it was such a big drama. And so if you'd looked at it a little bit differently, you might have said, hey, we'll put some burst valves at the top of those tanks, so if you do get a burst, it's going to shut off, and that would never have happened. You know, they ended up with I would have said, multi-million-dollar problem that, you know, maybe $20,000 worth of valves that are fixed up at the tank. So it's looking at the whole system and looking at, is it resilient, looking at other people's systems, particularly energy, and whether you have resilience there, and then looking at your big and unusual assets, and if you lost some of them, are you in the position to fix them, or do you have some workarounds for that?
Okay, Lexi, we maybe have time for one more to finish up with.
I think that was actually our last question.
Okay, well then I just wanted to mention one other thing that's kind of come up in the past, and we've been talking a lot about this lately, and kind of the issue around how sophisticated asset management has to be and how complicated. And it kind of ties back to what Ross was talking about earlier, which was, you know, keeping things simpler and not making them complex. So I wanted to kind of just talk just for a moment about a lot of what we've been telling people lately is asset management is really about asking yourself questions. Why do I do what I'm doing? What's the reason that we do this sort of maintenance or that sort of maintenance? Why do I replace the oil in my pumps once every 6 months? You know, what was that based on? Was that based on some analysis we did? Did somebody just tell us to do that 20 years ago and we haven't thought about it since? Even though pumps and oil have changed substantially, we still do the same thing we've always done. And it's really about questioning, you know, simple questions to yourself. You know, do we do the right things to our pump station? We send somebody out there once a week to do 2 hours worth of maintenance. What do they actually do when they get there? And is that the right set of stuff for them to be doing? And then using whatever tools we have, and maybe it's a simple spreadsheet, maybe it's some data on some paper forms that we have out at the pump station. You know, maybe it's a computer program that we've bought, maybe it's a GIS system. So whatever tools we have, and the power of the knowledge of our operators and managers of our system, we kind of put that to bear on these various questions to see if there's better answers. And a lot of times systems will find that they have much better answers when they take a look at those questions, and they can save themselves a lot of money. One utility that came to a training a couple of weeks ago had the very question of why are we changing the oil twice a year in our pumps, and did some analysis of the oil and found out that that really was not what they should be doing. And at the very least, they could go to once a year and possibly even every 18 months or maybe even every 2 years to replace the oil. And it was going to save them considerable amounts of money. We're talking tens of thousands of dollars every time they replace the oil. So just asking yourself the question can be a really key thing. So instead of focusing a lot on what program should I be using, which, you know, a lot of people want to head down that road. What program should I use? Should I use, you know, this manufacturer's program or that manufacturer's program? But, you know, keep it off, you know, not have that be the focus so much as how should I ask myself questions? How can I get data to answer those questions? And how can I maybe improve my operations by just, you know, asking myself these simple questions about why I do what I do, and focus more on that as, you know, the thinking piece that goes into asset management, which I think is the way more important part is, you know, thinking about things, getting data to help you answer those questions, and then answering them in a better way to save yourself money and time and effort and that kind of thing. So I think Lexi wanted to put out a poll question real quick just to see if anybody wanted assistance. Is that correct, Lexi?
Sure, yeah, I'm going to launch that poll now. So Heather, if you'd like to explain a little bit about the assistance that we're offering, how will people answer?
This is a poll related to the program I mentioned, that's the Smart Management for Small Water Systems. The Environmental Finance Center Network has the ability to assist communities with financial and managerial capacity issues, and that could be rate setting, it could be asset management, it could be energy efficiency, water efficiency, regionalization, funding sources, anything like that that's managerial. Most of the assistance will be done via email, phone calls, remote type assistance, but there's quite a few things that we can do to help people. So if you have an interest in having some of that kind of assistance. And keep in mind, this is limited to systems 10,000 and fewer in population because of the particular funding source. And it's also limited to water utilities. So unfortunately, on this particular funding source, we're not able to assist wastewater utilities. But if you have a need, you have something you think we can help you with, please complete the poll and we'll get back in touch with you and find out, how we can help you in that area. And then just as, oh, go ahead.
Go ahead, Heather.
I was just going to say, and while the poll's concluding, I just have our name and contact information for myself and Ross. So if after the webinar you have additional questions or thoughts or stories you want to share, I'm always looking for good stories on asset management. It's always fun to hear your journeys and the things that you're experiencing. So if you ever want to share any of those, please feel free to email. And also remember the resources, the informanage.com website that has a lot of good resources, and the EFC network. And there will be a recording of this webinar. If there's any questions you want to listen to, or you want to have anybody else that you know listen to it, that'll be up on our EFC network website soon.
Yeah, and we will try to get to any questions that you all sent in the last couple minutes that we didn't get to. We'll try to answer those as well in an email. I'll let you know when all of those materials are posted on our website. And I do just want to ask if you could take a few minutes before you check out completely. We do have a short survey that we are asking you to fill out just to give us feedback on how the webinar went today, and that helps us improve our webinars in the future. So you should see a link to that survey come through your chat box, and it will also come in the email following the webinar. And I think with that, we are ready to call it a day. Thank you, Heather, and thank you, Ross, and thank you all for joining us this afternoon.
Yes, and I'd like to add my thanks to Ross. Ross was kind enough to share his time with us, all the way from New Zealand. So thank you again, Ross, for being willing to share, and thank you, Lexi, for hosting, and thank you all out there for attending.
All right, thanks. Have a great afternoon.